Hey everyone, welcome. Today, we're going to dive into two math problems that are really more like stories. Now, on the surface, they seem super simple, but they're actually designed to trick our intuition. Let's see if we can uncover the secret they're hiding inside.
So, we've got two completely different scenarios. One is about a couple of guys mowing a lawn, and the other is about a road trip. They sound worlds apart, right? Well, here's the twist. The math hidden deep inside these stories is exactly the same. And figuring that out, that's the key.
Okay, let's set the stage. Here are the two everyday puzzles we are going to solve together.
So our first puzzle is a classic work problem, all about teamwork and getting a job done. The second one is all about travel, speed, distance, and time. Let's get right into the details.
All right, here are the specifics. Problem 1. Matt can mow a lawn in 3 hours. His buddy Ryan can do the same lawn in 5 hours. So the question is, how long would it take them if they worked together? And problem 2, Daniel drives to the airport at a steady 60 miles per hour. But on the way back, traffic's a nightmare, and he can only go 40. So what's his average speed for the entire round trip?
Before we go any further, what's your first instinct? What's your gut answer? Our brains are really wired for these quick, common sense answers, and believe me, these puzzles are specifically designed to play on that.
No, seriously, go ahead and pause right now. Grab a piece of paper, jot down what you think the answers are. It's the best way to really feel that aha moment that's coming up.
All right, welcome back. If those problems felt a little bit trickier than they looked, well, you are definitely not alone. Let's talk about the clever little common sense traps they set for us. So, the moment of truth. How did you do? For the lawn mowing problem, the most common guess is 4 hours, right? Just the simple average of 3 and 5. And for the driving problem, most people jump to 50 miles per hour, the average of 60 and 40. But look at the actual answers. They're close, but they're not quite right. If you made one of those guesses, don't worry. You've just experienced the trap firsthand. So, why does this happen? Well, these stories trick our brains into taking a shortcut. We want to average the most obvious numbers we see, the times or the speeds, but that shortcut doesn't actually fit what's happening. For the lawn, we need to add up how much work they get done per hour, their rates, not just average their finish times. And for the drive, Daniel spends more time driving at that slower speed, and that's what pulls the average down. The whole key is understanding what you're really supposed to be combining. But here's the good news. There's a master key, a single, powerful idea that unlocks both of these problems and helps us see right past the surface-level story to what's really going on underneath.
And this really gets to the heart of what we're talking about today. The words, the story about mowing a lawn or driving a car, that's all just wrapping paper. Inside, you find the same beautiful underlying mathematical structure.
And here it is. The master key is the idea of an overall rate. It's a simple formula that is always true. It's your total output divided by your total time. Now, output is just a word for whatever's getting done. It could be lawns mowed, miles traveled, you name it. This one simple formula is our guide. So let's put this one big idea to the test. Let's see how it just cracks both of these puzzles wide open, step by step. Okay, let's start with the lawn mowing problem. The trick here is to stop thinking about total time and start thinking about their rates. How much work do they do per hour? Well, if Matt does one job in 3 hours, his rate is 1/3 of a job per hour. Ryan's is 1/5 of a job per hour. When they work together, we just add their rates. A little fraction math, and that comes out to 8/15 of a job every hour. All right, this is the crucial step. We know they complete 8/15 of the job every single hour. But the question asks how long it takes to do one full job. So to figure that out, we just need to divide that one job by their combined hourly rate. We're really just asking how many of these hourly chunks of work fit into one whole job. And when you do that division, 1 divided by 8/15, you get 1.875 hours. That's about 1 hour and 52.5 minutes, which makes total sense, right? It's got to be faster than Matt could do it all by himself. So, just to recap the process real quick, we converted their individual times into work rates, we added those rates together, and then we used that combined rate to find the total time for one single job. It's a clean, logical flow once you see it. Now for the road trip, can we use our master key here? Total output over total time? Absolutely. In this story, the output is just the distance traveled.
Now, the problem doesn't give us a distance, so let's just pick an easy number that works well with 60 and 40, like 120 miles. That means the total distance for the round trip is 240 miles. The trip there took 2 hours, and the trip back took 3 hours, for a total travel time of 5 hours.
And there it is, total distance of 240 miles divided by the total time of 5 hours gives us an average speed of exactly 48 miles per hour. No tricky averaging of speeds needed, just our master key formula.
And you know, here's the truly elegant part. We just picked 120 miles to make the math easy. But what if we didn't? It doesn't matter. If you just use the letter D to stand for distance, you'll see that it actually cancels itself out of the equation. The structure of the problem is so strong that the answer is always 48 miles per hour, whether the airport is 10 miles away or 1,000. It's all about the ratio of the speeds, not the specific distance.
So, why did we just spend all this time on two little math puzzles? Well, because understanding them goes way, way beyond just getting the right answer on a test. This is so much more than just homework. Learning to see past that surface-level story and find the real mathematical structure, that builds what you might call rate sense. And that skill is the foundation for everything from fractions and algebra to science concepts like speed and density, and for tons of real-life decisions about time, work, and travel.
If there is one big takeaway from all of this, it's this. An average isn't just a random calculation. It has to be meaningful. It has to accurately tell the story of the situation. So the question you should always ask yourself is, what am I really averaging here? Is it time? Is it distance?
And that leaves us with a much bigger question. These puzzles show us that mathematics isn't just about crunching numbers. It's about learning to read the stories the world tells us, identifying their hidden structures, and building models that make sense of it all. So, what does it truly mean to do mathematics? That's something to think about.